Now let us see the students of 12th standard. Most important topic, deriving equation of the motional electromotive force, that is motional EMF, E equal to minus LBV for a rod which is sliding over two arms of a U-shaped conducting frame placed in uniform magnetic field. The question can be asked like this one. So first of all, what is the definition of motional electromotive force? The induced EMF produced in a coil due to change in magnetic flux linked with a coil, which is all due to some kind of motion, is called the motional EMF. So what is definition? Induced EMF produced in a coil. किसकी वजह से? ड्यू टू चेंज ऑफ मैग्नेटिक फ्लक्स लिंक्ड विद द कॉइल, एंड ये चेंज ऑफ मैग्नेटिक फ्लक्स किसकी वजह से? विच इज ड्यू टू सम काइंड ऑफ मोशन, इज कॉल्ड व्हाट? मोशनल ईएमएफ. To derive the equation of this motional EMF E equal to minus LBV, we consider this diagram. In this diagram, you can see that this kind of the cross indicating magnetic field lines going inside perpendicular to the plane of the board. That means outside the board you can imagine there is a north pole of one powerful magnet. Backside the board you can imagine there is a south pole of the another magnet. But both north and south poles should be having the same dimensions. Then in the region between north pole and south pole there will be an existence of such kind of magnetic field lines which are mutually parallel to each other, and you can see it is a uniform magnetic field. In this uniform magnetic field we are placing, this is a one rectangular U-shaped conducting frame or U-shaped conducting wire, and this U-shaped conducting wire is placed like this one so that its plane remains perpendicular to the magnetic field, and over these two parallel arms a one rod PQ is allowed to be sliding. In order to slide, you have to just consider a one string, then that should be tied up with this rod, and it should be allowed to pull towards the right side or towards the left side. Accordingly, this rod PQ is sliding, and as the rod PQ is sliding, the magnetic flux linked with this closed circuit goes on changing due to change of magnetic flux, and it is due to motion of the rod between two ends of the rod. A certain voltage is developing, and that is known as what? Motional electromotive force. Let us see how is it possible. The U-shaped conducting wire is placed inside a uniform magnetic field vector V, which is perpendicular to the plane of the paper. The magnetic field is perpendicular to the plane of the paper, and a U-shaped frame is placed in this magnetic field so that the plane formed by it should remain perpendicular to magnetic field. Then a conducting rod PQ is sliding over the two parallel arms of this frame with constant velocity V towards the right side as shown in figure. Assume that there is no loss of energy due to friction, and the rods this two parallel arms के ऊपर स्लाइड कर रहा है तो फोर्स ऑफ फ्रिक्शन क्रिएट होता है. लेकिन यहाँ पे हमको ये इस तरह का इसका मोशन लेना है कि जिससे कि रॉड से प्रोड्यूस होने वाला, रॉड की मोशन से प्रोड्यूस होने वाला फोर्स ऑफ फ्रिक्शन एज शुड बी एज पॉसिबल negligible, and that's why there is no loss of energy due to friction. Then let PQ be the position of the rod at any time t. ये रॉड इस तरह से मूव कर रहा है तो मूव करता करता यहाँ पे आता है, तब भी से द टाइम t पे इसकी पोजीशन कौन सी? PQ. तो PQ be the position of the rod at time t. So PQRS forms a closed circuit enclosing an area. तो कौन सा एरिया? ये एरिया. We suppose this length RQ equal to x, this breadth is equal to SR is equal to small l. That means this perpendicular distance between these two parallel arms is equal to small l, and that is considered as the length of the rod PQ. That's why what will be the area of this rectangle portion will be equal to L into S. So area LS that changes as the rod PQ moves towards the right side. तो जैसे जैसे आगे जाएगा वैसे वैसे डिस्टेंस x बढ़ता जाएगा, डिस्टेंस x बढ़ता जाएगा तो लेंथ x बढ़ती जाएगी तो Lx एरिया बढ़ता जाएगा। अगर ये रॉड लेफ्ट साइड जाता है तो x की वैल्यू कम होती जाएगी तो एरिया कम होता जाएगा। दैट मीन्स द एरिया गोज ऑन डिक्रीजिंग। एज इट मूव्स टू द राइट साइड द एरिया गोज ऑन इंक्रीजिंग। So as it moves to the right side, the value of dx increases. That's why dx by dt is velocity v is positive. If the rod is moving towards the left side, then dx by dt is negative velocity. So here, as the rod PQ moves towards the right side, so magnetic flux linked with the circuit also changes. As a result, an EMF is induced across these two ends of the rod PQ, and hence the induced current flows through the क्लोज सर्किट। अगर ये रॉड PQ का P एंड पॉजिटिव है देन करंट विल फ्लो फ्रॉम P टू S, S to R, R to Q and Q to P. So that will be the electric current I can flow in the circuit. I will show later on. This end works as positive, P end works as positive terminal and Q end works as negative terminal. That we see later on. How does it possible? So the current will flow in this anti-clockwise direction in such a circuit. Let RQ equal to X. Let RS equal to PQ equal to small l. Then at any time the magnetic flux linked with this closed circuit PQRS equal to B into A. क्योंकि ये closed circuit इस तरह से, तो इसका वेक्टर एरिया कैसे आप ले सकते हैं, going inside, perpendicular to the plane of the ball. Magnetic field is also be going inside. Both vector B and vector A being in same direction. Flux BA cos 0 is 1. That's why it is BA equal to B into area of PQRS2 equal to B into Lx. So magnetic flux is BLx. As the rod goes on sliding, the value of x goes on changing with time. Then the rate of change of magnetic flux will induce an EMF in a rod according to Faraday's law of electromagnetic induction. So E equal to minus d phi by dt equal to minus d by dt of BLx, where B is constant, L is constant, x is changeable. So minus BL into dx by dt equal to minus BLV, so where dx by dt is equal to velocity of the rod. अगर ये रॉड PQ राइट साइड के बदले में लेफ्ट साइड जाता है तो dx by dt आपको क्या कंसीडर करने का, नेगेटिव वेलोसिटी। तब आपको क्या मिलेगा, इंस्टेड ऑफ माइनस BLV इट विल बी प्लस BLV। तो मोशन ऑफ द रॉड इज रिस्पॉन्सिबल फॉर जनरेशन ऑफ दिस इंड्यूस्ड EMF, सो इट इज कॉल्ड व्हाट, मोशनल EMF। तो हियर वी आर नॉट चेंजिंग द वैल्यू ऑफ मैग्नेटिक फील्ड, बट वी आर just moving a rod, and because of which the area goes on changing, and as the area changes the magnetic flux changes. Magnetic flux changes, so EMF is generated, and that's why the rod PQ behaves like a battery, one end having positive terminal, another end having negative terminal, and voltage generated between these two ends is equal to product of B, L and V. So magnitude of this EMF is positive B, L, V. Now let us see again the derivation of E equal to BLV by using a Lorentz force. So motional EMF E, derive an equation of motional EMF E equal to LBV by using the Lorentz force. So actually here in the earlier topic we have seen that there was a U-shaped conducting frame, and on the U-shaped conducting frame the rod PQ was sliding over the two arms. So here it is not necessary that U-shaped conducting frame. Without U-shaped conducting frame also you can generate the value of induced EMF between two ends of the rod, and as shown in this diagram you can see this is again magnetic field lines are going inside perpendicular to the plane of the rod, perpendicular to the plane of the paper. Rod PQ like this one is going to be moving towards the right side with velocity of v, such that the plane of the rod should remain perpendicular to magnetic field. Now we know this rod is conducting rod, and as it is conducting rod, it is made up of positive ions and electrons. Positive ions are fixed at their lattice points, but electrons are free to move within the entire rod from its one end to another end. And that's why here the motional EMF will produce is due to the motion of these electrons. तो कैसे देखिए यहाँ पे, as the rod is moving towards the right side with velocity of v, then all the electrons and positive ions are also be coming to motion with the same velocity in the same direction towards the right side. It is just like that one. If you are traveling by a train, then which will be the direction of motion of velocity of a train, in that direction all the passengers are also said to be in motion. The same thing is here. So electrons and positive ions are also be coming to motion towards the right side with the same velocity as that of velocity of the rod. So consider a rod PQ moves with constant velocity of v in magnetic field with its plane perpendicular to the magnetic field. Any arbitrary charge, अब हम पॉजिटिव नेगेटिव चार्ज, पॉजिटिव आयंस का चार्ज, पॉजिटिव नेगेटिव इलेक्ट्रॉन का चार्ज भी हम कंसीडर करते हैं Q. तो एनी आर्बिट्ररी चार्ज Q in conductor PQ also moves with the same velocity v as that of the rod in the same direction but perpendicularly in magnetic field. तो इस तरह से मैग्नेटिक फील्ड, इस तरह से तो मैग्नेटिक फील्ड को परपेंडिकुलर डायरेक्शन में कोई भी चार्ज भी मोशन में होगा. अगर चार्ज मोशन में है तो एज यू स्टडी the Lorentz force acting on this charge is given by vector F equal to Q into vector V cross B, and from the vector product V cross B you can determine the direction of the force. तो vector V इस डायरेक्शन में है, मैग्नेटिक फील्ड B इस डायरेक्शन में है, तो अब V को B की ओर घुमाइए, तो V को मैंने B की ओर घुमाया तो कौन सी डायरेक्शन मिलेगी, इट इज कौन सी डायरेक्शन मिलेगी, इट इज एंटी क्लॉकवाइज डायरेक्शन. अब यहाँ पे ये जो प्लेन मिला उसमें इस तरह से आप स्क्रू घुमाइए तो दैट स्क्रू विच विल मूव्स इन वर्टिकली अप इन एंटी क्लॉकवाइज डायरेक्शन. तो अपवर्ड की डायरेक्शन में क्या लगेगा, फोर्स लगेगा किसके ऊपर, पॉजिटिव चार्ज के ऊपर. यानी कि लेकिन पॉजिटिव चार्ज तो कैसे मूवेबल है ही नहीं. तो अब यहाँ पे इलेक्ट्रॉन का चार्ज कैसा है, नेगेटिव. तो इलेक्ट्रॉन का चार्ज नेगेटिव, इसीलिए फोर्स कैसा हो जाएगा, ऑपोजिट, यानी कि डाउनवर्ड डायरेक्शन में. दैट्स व्हाई दिस काइंड ऑफ द चार्ज Q be the charge of electron which will start to move in vertically downward direction. So that magnitude of force will be equal to what, Q VB sin 90 degree, and sin 90 is what, so answer is what, F equal to Q VB. So magnitude of this force, Lorentz force, is Q VB and its direction is towards the Q end from P से Q end. किसके ऊपर, be remember ये इलेक्ट्रॉन के ऊपर, Q end of the rod. All the charges like electrons experiences the same force in magnitude and direction irrespective of their position in the rod. तो रॉड के अंदर चाहे वो कहीं पर भी किसी भी पोजीशन में हो, लेकिन सारे इलेक्ट्रॉन्स के ऊपर फोर्स कैसा लगेगा, नीचे डाउनवर्ड डायरेक्शन में कितने मैग्नीट्यूड का, QVB का, एंड किस डायरेक्शन में, फ्रॉम P से लेके Q एंड तक का. देन वर्क डन इन मूविंग द चार्ज फ्रॉम P टू Q. तो यहाँ से लेके यहाँ तक तो कितनी वो लेंथ L पे जितना डिस्टेंस ट्रैवल करेगा, तो फोर्स वर्क इक्वल टू क्या, फोर्स इनटू डिस्प्लेसमेंट. डिस्प्लेसमेंट यानी क्या, एंटायर लेंथ ऑफ द रॉड. तो क्या मिलेगा, फोर्स इज QVB इनटू L. And we know EMF is nothing but the work done per unit charge. So W upon charge Q will be equal to what? So W upon ये charge Q will be equal to क्या मिलेगा, VBL. That means induced EMF in this rod between these two ends will be equal to what, BVL. And as I was said earlier, so this kind of the, so this P end, which तो यहाँ पे electrons are gathered because of which this Q end becomes negative, and at the same time the positive charge which will open up at this upper end, that's why this P end which will works as positive and Q end which will works as negative, and just like as a one battery. कैसे देखिए अभी यहाँ पे the next topic में, the origin of generation of the induced EMF. So in the answer of this question you have to write this first paragraph and the same diagram, and then you have to start to write this portion. इसीलिए देखो यहाँ पे एरो बताया है. तो यहाँ पे फिर से कंसिडर रॉड PQ moves with constant velocity of V in magnetic field B with its plane perpendicular to magnetic field, and then the positive ions, जैसे आगे आपको मैंने बता दिया in explanation में, positive ions and electrons in the rod will also move with the same velocity as that of the rod in the direction of motion of the rod. So they experiences the Lorentz force F equal to Q into vector V cross B. Therefore, the magnitude of force is QVB. The force acting on positive ions is from Q to P. तो पॉजिटिव आयंस के ऊपर फोर्स कैसे लगेगा, ऊपर की ओर. but positive ions, as I said earlier, are fixed at the latest points, so they don't move. वो अपनी जगह से हिलेंगे नहीं, but electrons are free to move, and that's why the force acting on them is from P to Q in opposite direction में लगेगा, P से Q की direction, because इलेक्ट्रॉन का चार्ज नेगेटिव है, इसीलिए चार्ज नेगेटिव तो फोर्स भी नेगेटिव, तो फोर्स नेगेटिव मतलब now the force which will act in direction from P to Q on the electrons. So these electrons are depositing at Q end. So they deposit at Q end of the rod and make it negatively charged. इसलिए Q end कैसा हो जाएगा? Negatively charged. Just like इस बैटरी, आपके पास ड्राई सेल हो तो इसके पास पॉजिटिव नेगेटिव टर्मिनल, तो नेगेटिव टर्मिनल की तरह ये Q end वर्क करेगा and make it negatively charged. At the same time, the resultant positive charge appears at P end. तो उसी के समय ऊपर की एंड पे पॉजिटिव चार्ज ओपन अप होगा, मतलब P end works as positive end. So thus P end becomes positive and Q end becomes negative, and the rod PQ behaves like a one battery, behaves like a dry cell of electromotive force E equal to LVV. तो जिस तरह से 1.5 वोल्ट का ड्राई सेल होता है और वोल्टेज 1.5 जनरेट करता है, तो इसी तरह से ये रॉड भी कितना वोल्टेज जनरेट करेगा? L into B into V. तो L क्या है? लेंथ ऑफ रॉड, B क्या है? यूनिफॉर्म मैग्नेटिक फील्ड, V क्या है? वेलोसिटी का मैग्नीट्यूड, कितनी वेलोसिटी के साथ मूव होता है, बराबर। तो यहाँ पे ये टॉपिक फिनिश होता है। वन मोर पॉइंट, अब ये चैप्टर में आपको क्या सीखने को मिलता है? इन चैप्टर 4 व्हाट यू हैव स्टडीड? इन चैप्टर 4 यू हैव स्टडीड अबाउट द ऑर्स्टेड ऑब्जर्वेशन. व्हाट वाज ऑर्स्टेड ऑब्जर्वेशन? यू हैव सीन दैट व्हेन one magnetic needle is kept parallel to the conducting wire, parallel to the conducting wire, and in this conducting wire when electric current I is allowed to flow, then this kind of the magnetic needle deflects. How does it deflect? It deflects perpendicular to the length of conducting wire, perpendicular to the current direction of conducting wire. It means what? कि ये electric current carrying wire वो क्या करते हैं? तो यानी मूविंग चार्जेस आर अप्लाइंग द फोर्सेस ऑन मैग्नेटिक नीडल, मतलब मैग्नेटिक फील्ड पे. देखिए यहाँ पे, तो यू हैव स्टडीड दिस थिंग इन चैप्टर 4. तो चार्जेस इन मोशन यानी करंट कैन एक्सर्ट ए फोर्स or a torque on a stationary magnet. So this thing you have studied in lesson number 4. अब इसका opposite, conversely, a bar magnet in motion, that is a changing magnetic field, can exert a force on a stationary charge. जो आगे हमने देखा था फैराडे का एक्सपेरिमेंट, मैग्नेट वॉज मोशन कमिंग टूवर्ड्स द कॉइल, एंड कॉइल कौन सी बनी हुई है? कंडक्टिंग वायर की, मतलब इसमें चार्जेस है, चार्जेस कैसे स्टेशनरी. तो ये when magnet is in motion, that means there is a changing magnetic field. तो changing magnetic field due to change of magnetic flux की वजह से ये कॉइल में क्या जनरेट करता है? करंट जनरेट करता है. करंट जनरेट करता है मतलब क्या? दिस चार्जेस इनसाइड द कॉइल कम इनटू मोशन. क्यों मोशन में आया? क्योंकि इसके ऊपर फोर्स लगा, और वो फोर्स लगने की वजह से, तो कौन सा फोर्स? इस तरह का ऐसे फोर्स लगता है. तो देखिए, ये बार मैग्नेट इन मोशन, दैट इज ए चेंजिंग मैग्नेटिक फील्ड, can exert a force on a stationary charge. So thus you can say that from this point of view, electricity and magnetism are related with each other. तो electricity से magnetism create होता है, magnetism से electricity